Normally, if you were to attach the normal manage debugger to that process in production and hit a manage breakpoint on a retail build, you're not going to see anything. And that's because the JIT compiler optimized the code and it removed something called sequence points from that function. So we asked the JIT compiler to recompile it with those optimizations disabled for the duration of the breakpoint, and we put the sequence points in place. And then once the breakpoints hit, we re-JIT it back to fully optimize. All right, I've got the snapshot debugger started against real Azure. I can come in here and set a production breakpoint on this line here. And you can see the breakpoint, not a production breakpoint, sorry, it's a snap point. Production breakpoint was an old name for it. Set the snap point on this location, and you can see it's purple. It's not the normal color of a breakpoint. You can also see that it hasn't bound yet. And the reason for that is if you want to push multiple snap points up simultaneously, we want to do that atomically. So you actually have to push a button that says, update these against the server. So I'm going to go ahead and click that button that says I want to update them. It's going to push it up to my live server, and now it's filled in and bound. So it's just like a normal breakpoint in the debugger. If I come in here, right mouse click on my app service, and say that I want to view it in the browser, it'll come up, running on real Azure, and you notice the breakpoint turned green. And there's a new event in the IntelliTrace window that says that a snapshot was taken. The snapshot's sitting on the server, but as a user, I can sit here and fully interact with this. There is almost no noticeable difference in terms of the performance of the application. We have some good performance analysis of this available on the internet, on the blog post that introduced this technology. So sit here and interact with the app, and it's running great. Okay, now the developer comes by and wants to actually see what's going on. So I can click on the snapshot and click View Snapshot. Now it's going to launch the remote debugger on that app service, because this was an app service application, and it's going to attach it to that snapshot instead. So while that happens, just sit here and continue to play with it. It's still responding. There's nothing as a user that makes me aware of the fact that I'm being debugged, or the application that I'm using is being debugged. And once the remote debugger actually comes up, the call stack will be visible, and I'll be able to view the entire heap of that location. Other features of snap points, while this comes up, are you can set conditions on them, and those conditions use the same syntax that the regular conditional breakpoints in the debugger use, but the conditions are evaluated virtually against the process. Come on, you can do it. All right. Well, that connects really quick. I'm going to ask, does anyone in here write any C++ code or any C++ does? All right, there's a few. Awesome. We have some cool new features in C++. I'm happy to announce that C++ actually supports the same snapshotting features that C# does. Oh, I did. So I'll go back to that in just a second. So here's the call stack, and I can evaluate my variable. And this is evaluated against the live server. And the reason that says the debugger is unable to evaluate the expression is there's a debugger display attribute on that can't be executed right now. And like I said, this is running against real Azure. It's on the West US data center, so it is remote debugging across the cloud here. And over Wi-Fi on a loaded Wi-Fi system. Okay, the entire managed heap, yay! All right, so it's enough with the snapshot in C++ and C#. I'm going to switch to a C++ app.